sort of given some homework. So let's see if we can start with that homework. And some of you said that you have gone through that, either attended the original lecture or went through the replay, and you know about the homework. Okay, so all right, let me start with somebody who has attended the last time, not attended, but at least I think you did. Raghav, did you attend last time's talk?
Yes, ma'am, I was there.
All right. So you know that this is the homework. There were 4 questions over here. And we
Yes,
talked a
ma'am.
lot about retinoblastoma gene and its protein and TP53. And retinoblastoma gene was supposed to be, the gatekeeper, or sometimes called the governor of the genome, and TP53 was called the guardian of the genome, right? And they're very important in as tumor suppressor genes. And yet, when you have null mice, Raghav, do you know what is a null mouse?
Where the P53 has been knocked out?
Completely. And the retinoblastoma gene has been knocked out completely. So that means any null mouse for any particular gene is got both the alleles that have been knocked out. Yes?
Yes.
And yet these mice, and this is so important, retinoblastoma gene and T53. So why do they develop normally, Raghav? Because right from the embryo, the embryological stage, they don't have these genes. Any clue as to why this happens, Raghav?
Ma'am, one reason could be that there are other
Loudly, if you can, Raghav. I don't know whether I'm the only one who's hearing it low. Can you come closer to it?
Am I audible now, ma'am?
Yes, you are. Can you, is there any way you can push it up a little bit more, Raghav? No?
No, I'm doing it.
Okay. Yeah, come on. Yes.
Is it better now, ma'am?
Oh, yes, I think so.
So, ma'am, one reason could be that there are alternate pathways also which can suppress the tumors apart from the RB and P53. So they can be the PI3K AKT pathway also.
Okay. So you said that there are, yes, continue. Sorry, Raghav. Finish your thought.
So, ma'am, one of the pathways, as I said, ma'am, can be PI3 AKT pathway, which basically regulates the cell growth. And apart from that, there are others also, but those are specific, like the APC pathway or the notch or the hedgehog pathway. So apart from these 2 main, there are other pathways also which may suppress the tumors.
All right. Did you notice, Raghav, that I said that the mice develop normally?
Normally.
Okay, what do we mean by develop normally? We're not really here talking about tumors, right? Okay, we talk about retinoblastoma gene and TP53 as tumor suppressors. But what are they actually doing, Raghav?
They're regulating the cell cycle.
Exactly. So they are regulating the cell cycle. And they are regulating the cell cycle in a very important kind of way. So, if their importance is such in the regulation of the cell cycle, then how is it that the embryo develops normally into a normal mouse? That's what we're talking about. The question of them in later life getting tumors is a secondary story, right? And because we talk of them as being such powerful protectors of the cell cycle. So why, and apoptosis and several other functions, at least as far as P53 is concerned, it's cell cycle, it is apoptosis, and so on. So why do these mice develop normally? And you were on the right track, Raghav, except you said that, talked about it as being tumors. because I hope everybody in the audience, and I hope the students who are there today understand that God didn't give us tumor suppressor genes, or for that matter, oncogenes, so that we could either suppress or produce tumors. Yeah, you understand that, Raghav, don't you?
Yes, ma'am.
Yes, so they're not there to either suppress tumors or, as in the case of oncogenes, to actually promote tumors. They have a normal cellular function. Okay. So now,
Ma'am.
yeah. So now tell me, you were really on the right track. So what did you say, Raghav? Tell me.
That there are other pathways also, like I started with the PI3K
Yeah, there were many
AKT
other
pathway.
pathways. So I think that we seem to or believe, because we are concentrated on tumors, that if you don't have retinoblastoma or you don't have TP53, that you will at all, then there is something wrong with your entire genomic cycle, and you will probably not develop at all. Okay, let alone the question of having tumors. But that's not so. Nature is abundantly, has so many alternatives to one sort of thing. All right. And so the answer to that question is there is a huge redundancy in the system. So you don't have a P53. There is another pathway that will become important in those kind of animals. We can't do the experiment in humans, okay? Because we don't have really a P53 null system right from the time we are embryos. At least we don't know about such a thing. Yes, but we do know that if you have one P53 allele that is abnormal, during life, when the other P53 allele is knocked out, we get tumors, and that is known as the Lee-Fraumeni syndrome. And we assume that if there is a mouse that has got no P53 allele, then that mouse will not develop at all. But that's not true. There is a huge redundancy in the system. And once that mouse grows and is using another pathway, you may not get kind of tumors that you expect when both P53 alleles in post-natal life happens to be knocked out. Now with RB, it is a very interesting situation. The RB is very, very important in the development of the placenta. Trophoblast development is very dependent on having at least one allele of RB. So if you knock out both alleles of RB, mice will not develop. Okay, why? Because the placenta will not develop. But if you are able to keep that placenta going by putting back the RB in the placental, that means in the extra embryonic cells. You know what is the meaning of extra embryonic, Raghav? Can you explain? What are the tissues that develop from the extra embryonic part of the growing embryo, of the zygote? In other words, that is, what is embryonic and what is extra embryonic? Can you hear me, Raghav? Raghav is
reconnecting. He lost the connection.
He lost the connection. All right. So maybe we'll ask somebody else. So maybe we can ask Ajit. Ajit, are you there?
Yes, ma'am.
Yes, ma'am. Ajit.
Has some issues.
Extraembryonic refers to those
yes.
other structure other than the embryo, like the placenta, umbilical cord. Those are the structures which help
Placenta and umbilical cord. Anything else? What are the extra apart from the placenta? There are two very important extraembryonic structures, no? So what are they? One is the placenta. You're absolutely right. Anything else? Which disappears, the placenta disappears. It's not there in after fetal life, right? That means once a child is born, there's no more placenta. The placenta withers away. Anything else that withers away and withers away earlier than the placenta, Ajit? Anything that you can think of? All right, Akriti. This is general knowledge. You know the question, Akriti?
Yes, ma'am.
What are the extra embryonic structures? No, Akriti doesn't know. All right. Is Sriram there?
Yes, ma'am.
So tell them. What we know is the placenta. What is another
can it-
extra embryonic structure?
Can it be the umbilical cord, ma'am?
Umbilical cord. Okay. What else? No? And it disappears much before the placenta disappears. Asma? Asma, are you there?
Yes, ma'am.
Right. So can you think of something else? No? All right. Priyanka? Is Priyanka there or she decided to drop out? Are you there, Priyanka?
Yes, ma'am.
Right. Tell me, what is another important extraembryonic structure?
Yolk sac.
Excellent, Priyanka. Yes. So you have the placenta and you have the yolk sac. Okay. And in this case, when we're talking about retinoblastoma gene, all right, the retinoblastoma gene is extremely important in the development of the trophoblast. Okay, right from the beginning, those cells that are meant to become the trophoblast, you know that when a zygote is fertile, when the ovum is fertilized and a zygote is formed, there are some cells after the early, 8 stage, a cell stage, and the 16 cell stage, and then you have the blastocyst, and you know that there are parts of this structure that become the extraembryonic structures, that's the trophoblast and the yolk sac, and some that become the embryonic structures. Okay, so now here the trophoblast is very, very vulnerable if the RB, both the alleles are knocked out. But if you manage to replace the RB gene in the trophoblast and the placenta develops normally, the embryo develops without any problem at all. So the mice develop absolutely normally if the gene has been replaced in the developing trophoblast. So it seems almost as if the redundancy that we're talking about, which Raghav very rightly said, that there is a lot of redundancy in the system. Once, of course, the situation is set in stone, then the redundancy disappears. But during embryonic life, if one pathway is missing, then another pathway will take over the functions of this pathway. And it's very curious that you have the embryo and you have the extra embryonic tissue, in this case, the trophoblast. The trophoblast requires the RB gene, but the embryo does not. Okay, it develops very normally. Okay, let's go to the next question. All right, and the next question was what? Why are only a few organs the targets of cancer in the inherited syndromes? Anybody knew the answer to that question?
Yes,
I've given
ma'am.
the answer here, but did anybody find it out? Yes, anybody?
Yes, ma'am.
Sriram,
Mm,
did you find the answer to that? You know, no, that if you have, the Knutson's hypothesis.
yes, ma'am.
Yes. And so why do you only get a retinoblastoma? Because every cell in your body has got one one
Allele.
gene that is knocked out, and any other cell in the body, that cell could have the Knutson's, fulfill Knutson's hypothesis and have the other allele knocked out. So why are only a few organs the targets? So why only retinoblastoma? And you don't get a liver cancer, or you don't get a skin cancer or anything else.
Is it because once that mutation or allele is knocked out, and during the course of that cell's progression and the events that it undergoes, which are specific to its location and maybe tissue architecture, it becomes more susceptible to tumorigenesis, is one thing that I thought of.
You thought of. Yeah, that's a good answer, in fact, because can we assume that, the gene, whatever gene that we're talking about, in this case, we're talking about retinoblastoma or P53 or any other, whether it's APC, and why do we only get polyps in the colon, and sometimes we also get some mesenteric fibromatosis in Gardner syndrome and so on, that is associated with APC. And we wonder, why is it that only some organs, every cell in our body has this gene knocked out in one, or in some way deficient in one allele, and it has to wait for the other allele to get knocked out. But why only in the colon in the APC, or why only in the and I think that Sriram has explained it quite well. You see that every gene, although it, in this case, the retinoblastoma gene, has such an important part to play in the cell cycle, it's not only a question of being important in the cell cycle, it is when is it important, at what stage of the developing cell. Okay, you know that we don't get retinoblastomas in adults. Okay, retinoblastoma and many of these syndromic things happen at younger ages. So the APC gene, you're not going to get an APC type polyposis only in adults. It starts very early. It starts, I wouldn't say that it starts at the age of 2 or 3, but by the time the individual is 12, polyps have already started developing, and you will get polyps that just keep on proliferating in that. So it's an early kind of story. So why does this happen early? It's because during as we see over here, developing tissues, okay, there is a particular stage in a particular tissue where that tissue becomes very vulnerable to the formation of tumors. And there's some interesting work that has been done. And I would say here, you see the second point, cancers initiate through the effects of oncogenic events only on susceptible cell of origin states. That means when the cell is most susceptible to this, and there are some cells that are very susceptible at a particular state. And here is a nice little paper. If some of you are interested, you can go and look it up. Yes, it was, you have the RB depleted. Now, suppose you don't have RB at all, and you have this maturing retina over there. Now, this maturing retina has got what they call the ARR3. Now, we needn't bother about that, so it's maturing. And then you have another ARR3 minus, which is not the immature ARR3, okay? Now, what happens is that you have these cone precursors, and as they enter into the cell cycle, they are proliferating. Now, in an RB depleted system, whether it's lost one or later on it loses two, in the Knutson's type of hypothesis, you find that it's only these ARR3 precursors that form retinoblastoma-like lesions. Okay, they actually form little benign tumors first, which are called retinomas, And we sometimes see retinomas in the human system, and they are almost invariably in patients who have a germline mutation in their genes. Okay, so it is about vulnerability again of cells or tissues where the cooperation of other cellular and tissue systems are required at a specific time point. So that's the reason. It is every cell in my body has this, but every cell in my body is not susceptible because of the fact that that particular gene, there has to be a combination of events that takes place in that particular cell for the this genetic event to initiate neoplasia. So that's the answer to that question. And I'm very happy, Sriram, that you thought about it and came up with a very interesting answer.
Thank you, ma'am.
All right, now here was the question number 3. Every one of us now does, and in many labs, I'm sure you know, that we are talking about, and those of you who attended the talk on cervical cancer, somebody gave you a talk, and I, if I remember right, it might have been from PTI Chandigarh. Now everybody's doing P16 because we want to know whether this is an HPV related tumor or a non-HPV related tumor. And if you do P16, you will, as a surrogate marker for HPV, you are able to label this tumor, whether it's a squamous carcinoma or an adenocarcinoma. When it's occurring in the cervix, we call it, or we suspect that it is an HPV-related tumor. We do the same thing in the oropharynx. The oropharynx is also susceptible to HPV. Of course, a lot of our oropharyngeal squamous carcinomas are tobacco-related. But in situations where tobacco is not part of the system, you find that HPV has a strong association with cancer, squamous carcinomas of the oral cavity. So tonsil, base of the tongue, supraglottic larynx, epiglottis, these are all oropharyngeal tumors, okay? Oropharyngeal squamous carcinomas, and we look for P16. So why do we look for P16 in the system and use it as a surrogate marker for HPV? Do you know what is the meaning of surrogate? Sonal, what's the meaning of the word surrogate? Is Sonal there? Sonal?
Yes, ma'am.
All right. So what is the meaning of the word surrogate? Do you understand the question? What is the meaning of the word surrogate? No, Sonal doesn't understand the meaning of the word surrogate. Okay. Is Akriti there?
Yes, ma'am.
All right. Will you like to explain to Sonal what is surrogate?
Ma'am, ma'am, it's a kind of a similar marker which can be used in others' place, like
A similar marker? You mean that it's telling you that it is a kind of a marker for HPV? You can use it anytime. Wherever it is used, it tells you that this is HPV. You think that's what it is?
no, ma'am.
All right. Let's ask Asma. What is the meaning of the word surrogate?
Supports the
Sorry?
main. It supports the main. It comes as similar as the test.
No, surrogate means in place of. So you're not testing the particular thing that you're wanting to test, but you know that in a particular system, if you use this other marker in place of that, you have a high correlation between this marker and what it is that you are looking for. Okay, and so the correlation of using this marker in place of whatever it is that you're looking for has a very high correlation. Okay, so P16 can be used in many, it's actually a cell cycle marker. And we did talk about P16 yesterday. I don't, sorry, 2 days ago when I was telling you about the retinoblastoma protein. How many of you actually realized it or went back and tried to think about it? So is there anybody there, like maybe Raghav, you want to talk about P16?
Ma'am, in case of HPV, actually E6 and E7 are involved.
I can't
E6,
hear you, Raghav, and I doubt that anybody else can. Maybe you need to be loud in close to the mic.
Am I audible, ma'am?
Yes, you are much better. So maybe you should push your,
Ma'am, in
your
case
chair
of
up. Yes?
ma'am. So in case of HPV, the E6 and E7 are involved basically. So E6 degenerates the P53 while E7 does away with the RP.
All right.
Now P16 is